Good morning, guys. Today we are starting a new unit on density. Density, our objective is that you will have a general understanding of density, volume, and dense. Those are three definitions. You'll have an understanding that objects are made of many tiny objects, too tiny to be seen. Your essential question. Explain the difference between density and volume. Here is a very good example of density. Density of matter, how tightly packed matter is, the amount of mass in a given space. So you see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's a gas, a liquid, and a solid. Well, the reason that the solid is more dense is because the matter is packed tightly in there. And then a liquid such as Coke or water or milk, it's not packed quite as tightly as the solids are, but then it's packed a little bit more than gas. So you can see a gas would be something that you can't see at all right, because it's very dense. And then a liquid, you would see where you could see that, but you could see how it would not be as heavy or would not have as much mass or as much density as a solid. So we go less dense to more dense. Okay, here's another density example. Both objects below the carts are the same size and can hold the same amount of mass. Object A has more mass or stuff inside of it, therefore, so here's A, it's got more stuff inside of it, more mass. So mass equals stuff, okay? Therefore, object A has greater density than object B, okay? So more stuff, more things means that it has greater density. And then here's another good density example. These two objects are equal in volume, but different in mass due to their density. Low density, so this looks like it must be a liquid. And then here we have, this is going to be a solid. It's got high density. And one of the things that I wanted to point out here too was that even though these are both solids, normally something with, you have a solid or a liquid or a gas, but these are both solids. So there are more things in this buggy, more stuff, so that's why this one has more density. All right. Got 3 vocabulary words, but I want to go over. I want to read this part to you first. What is density? The volume, amount of space an object takes up. Dense, heavy for its volume. Density, mass of a certain volume of a material. Now here, I went ahead and did this part for you so you won't have to do it, but you are responsible for knowing this, so you need to keep this and study over it. Definition of volume, the amount of space an object takes up. Here's a good image that gives us an example. A volume is the three-dimensional space occupied by solid, liquid, or gas. These are all examples of volume. So these are all examples of volume. All right. Synonyms for volume, bulk, and mass. Dense is our next word. Heavy for its volume, having parts close together with the space in between. Image. Here's density. Remember, these are more closely together, and these are not as close together, so this one's going to have more density on the right. Synonyms. Compact. These are in there, and they're compact. They're compressed, and they're kind of pushed together, and it's a thicker substance. See, there's no thickness really here, but this is a thicker substance. Density. Mass of a certain volume of material. This means how they're arranged. Okay? All right, so high density. Particles are packed together tightly, not much space in between. Just like we saw earlier, these are all packed closely together, so there's going to be more density. Low density. Particles are packed loosely together, and there's more space in between. That means they'll float more easily. An example of that would be wood. Synonyms: thickness and consistency. What is density? 2 boxes are placed side by side. You don't know what's inside the 2 boxes. You pick up each of them, and you can feel that one is heavier than the other. One box is filled with tennis balls. The second box is filled with baseballs. Why are the baseballs harder to pick up? The box with baseballs can be much harder to pick up because it has more mass. Even though the tennis balls and the baseballs are the same size, they are made up of different masses. Can 2 objects have the same size but different mass. Yes, mass does not depend on size. How many objects have the same size but a different mass? All matter is made up of atoms. Excuse me, y'all. All atoms have mass, but some atoms can be more massive than others. The more massive the atom, the greater is the mass. The greater is its mass. Thinking about the tennis and baseball example above, the baseball has atoms that are more massive. The atoms in the baseball are dense, which means that they are heavy for the amount of space that they're taking up. These atoms are packed more tightly together than the tennis balls, which is why they are harder to pick up. Why are baseballs harder to pick up than tennis balls? We just read it. The atoms are packed more tightly together than the tennis balls. Density. Density is the amount of mass of a material within a certain volume. Scientists have already determined that the density of many common materials. A chart of these materials can be found on the following page. Density is a physical property of matter. Knowing the density of a substance can help us identify a material. If you have a piece of metal but you aren't sure what type of metal it is, knowing the density can help you to narrow down the possibility of what it could be. Looking at the chart to the left, iron and gold are both metals, yet have different densities. So look here. This is the material on this side, and here are the densities. That's grams per cubic centimeter. Cork has 0.2, water 1, iron, and you can see the chart there. So how can looking at the chart to the left, iron and gold are both metals that have different materials. So how can density help identify material? Well, different materials have different densities, so knowing the density can eliminate it being something else, okay? Right here, that's where we got that from. You aren't sure what type it is knowing the density that can help you narrow down the possibility. Highlight that. Knowing the density can help you narrow down the possibility of what it could be. All right, so measuring the density of a solid, it's possible to measure how dense a material is. Knowing the state of matter of the object will determine how to find the density. To determine the density of a solid object, you need to find out its mass and volume. You can find the mass by using a triple beam balance. Once you have found the mass, you need to calculate the volume. If it is a regularly shaped object like a cube, a cylinder, or a sphere, you can calculate using a mathematical formula. You can determine the volume of an irregularly shaped object like a rock using a graduated cylinder. Once you have determined the mass and volume of the object, you will divide the two numbers to determine the density. The unit will be grams per cubic centimeter. Step 1, find the mass, okay? Step 2, find the volume. Step 3, find the density. So density equals mass divided by volume. All right, and you can just write that out as D equals M divided by V. All right, so we have practice questions, show your work. Mass, 270 grams, volume is 100 centimeters. All right, so let me change my color here. All right, so the mass we said is 270. Mass is 270, volume is 100. So I'm going to turn this sideways, and then I'm going to open up my calculator. When I taught the younger grades, that's how they would say it. Do we get to use a calculator today? We don't get to use a calculator today, y'all. All right, so anyway, the mass we see is 270, so I've got that here, 270, and the volume is 100, okay? So we would say 270 divided by 100 equals 2.7. 2.7 grams per cubic centimeters. This 3 makes it cubic, okay? All right, now next we are going to look at the mass, 10 grams. Mass is 10 grams. And then the volume is 10 grams. All right, so remember density equals M over V, density equals M over V. The mass is 10 and the volume is 10. So we would say 10 divided by 10. All right, 10 divided by 10 is 1 gram cubic centimeters. Measuring the density of a liquid. Similar to a solid, in order to determine the density of a liquid, you need to know the mass and the volume of the liquid. To figure this out, you'll need a graduated cylinder, a scale, balance, and the liquid. All right, so here's step 1, step 2, step 3, step 4. Again, density equals mass over volume. D equals M over V. And how does finding the density of a liquid differ from finding the density of a solid? When determining the density of a liquid, it is necessary to use a graduated cylinder to help determine the mass of the liquid in the graduated cylinder. And this is the page that you guys are going to do for me. There's 1, 2, 3, 4, 5, 6 questions. Have a good day, guys. See you tomorrow.